before I go on with problem 143, I actually have a bone to pick with problem 142. And I did it, we actually went through it correctly, although I probably did a couple of more steps than I had to, because when I do them in real time, my brain wanders. But now that I've had time to sit and look at it a little bit, I realize that I think the GMAT people may have made a mistake. So what was the problem? So the problem itself was 9 to the x plus 9 to the minus x is equal to b. And the problem is, do we have enough information to answer this question? That's how they phrase it. They don't say, do we have enough information to say that this is true? They say, do we have enough information to answer this question? So if I have enough information to say, no, this is not true, that should be that statement should still be good. So we can ignore statement number 1. In the last video, I showed that that was sufficient, and I still agree that that is completely sufficient. But let's look at statement number 2. According to the GMAT people, they say that statement number 2 is not sufficient to answer this question, and I'll argue that it is. Because they say that statement number 2 says that x is greater than 0, which is equal to b. I take this to mean that x is greater than 0, and 0 is equal to b, or b is equal to 0. Maybe I'm misunderstanding that, but that's the only way I can think of interpreting this thing. So if b is equal to 0, what is the statement that we're trying to see if we can answer, or the question that we're trying to answer? What does that boil down to? Well, then the question boils down to 9 to the x plus 9 to the minus x is equal to 0. And my question to you is, if I'm taking 9 to any power whatsoever, can I ever get 0 or a negative number? In fact, the only way I can get to 0 is if I do, 9 to the minus infinity power, right? Because that equals 1 over 9 to the infinity. So that might approach 0. But even if I said x was infinity here, on this side I would have 9 to the infinity here. So this would be infinity plus 0. So it would still approach infinity. So there's actually no way. And that's what the limit and all that. I don't want to get confused, but there's no way. Some people think, oh, if I'm taking to a negative exponent, maybe that becomes a negative power. No, a negative exponent just means an inverse. So this can be written as 1 over 9 to the x is equal to 0. So if x becomes a very large number, this becomes very positive, and this approaches 0. If x becomes a very, 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 very small fraction, this number becomes a small number, but then this is the inverse of a small number, so this becomes a large number. So no matter what I do, this stays. And actually, if x becomes negative, these just switch places, right? This becomes negative. This becomes 1 over 9 to the positive x. You get the point. These are just negatives of each other, these exponents. And if x was 0, then both of these are equal to 1. So then you'd get 2 is equal to 0. So actually, I don't know, the way I see it, statement 2 answers our question, but the answer is no. 9 to the x plus 9 to the minus x does not equal b, because statement 2 says b is equal to 0. But anyway, I don't want to harp on this too much, but I think they actually made a mistake, because statement 2, in my mind, answers the question. It just doesn't say that the question is true. Let's move on to the next question. Don't want to wait. But it's good. I think discussions like that, even though some poor chap, because apparently these are real GMAT questions, some poor chap might have gotten it wrong, but we can use that as a piece of instruction. So anyway, 143. They say if m is greater than 0 and n is greater than 0, is m plus x over n plus x greater than m over n? Interesting. So they're essentially saying, if I have m over n, and then I add the same number, we call that x, to both the numerator and the denominator, does that make the whole fraction bigger? And I'll just give you a little intuition right now. If I had a very small number for x relative to m and n, it doesn't change the fraction much. Although, well, let me put it this way: no matter if I add anything, whatever x is, and the larger x is, the more that this fraction is going to approach 1. And you think about it. If m is 1 and n is 2 and x is 1,000,000 and x is 1,000,000, then you're going to have, that million is going to overpower the m and the n. You probably remember that a little bit from your limits. But I just want to give you that intuition. Regardless of m and n are, if x gets suitably large, then this will approach 1. But I don't know if that's going to help us. Let's look at the statements. Statement 1. M is less than n. M is less than n. So if m is less than n, this says that this is going to be less than 1, so it's going to be a fraction. And I just said that if I add an x to the numerator and the denominator or something, you're going to approach 1. But we have to be careful because they didn't tell us that x is positive. So I might be subtracting x from the, maybe this x is a negative a million. Let me give you that example. So let's say m is less than n. So let's say that m is equal to 1, n is equal to 2. So we could say if x is a million, so let's do something similar. Let's say x is 100. So m plus x would be 101, and n plus x would be 102. And that is easily greater than 1/2, right? So you say, oh, excellent. Statement 1 is sufficient. But what if we were to, and first of all, that doesn't prove sufficiency, but it's easy to prove that it's not sufficient. Because what if I were to add, what if x were minus 100? Then it would be 1 minus 100 would be minus 99. And then 2 minus 100 would be minus 98. And is that greater than 1/2? Well, no, this is a little over minus 1. So it's a negative number. It's going to be less than 1/2. So statement 1 alone is not sufficient because I can pick an m and an n using statement number 1 and then an x, and I could pick different x's where the statement is either true or not true. This one is not true. I'm trying to cross that out. Let's look at statement number 2. Statement number 2 tells us that x is greater than 0. So let's think about just x being greater than 0 alone. Does that help us? Well, it does help us if m is less than n, right? Because I just gave the example that if m is less than n, so if you're starting with some fraction that's less than 1, right? If you start with some fraction that's less than 1 and you add a positive number to both the numerator and the denominator, you're just going to get a little bit closer to 1. So you're actually going to increase the value of that fraction. And you could test it out on a bunch of different numbers, right? If you add 1 to the numerator and the denominator of 1/2, you get 2/3. If you add another 1, you get 3/4. If you add another 1, you get 4/5. So you see how this continuously, as you add more and more to the numerator and the denominator, it approaches 1. And this x greater than 0 satisfies our problem with the first statement, because our first statement says, oh, what if x is negative? Then it doesn't work. But let's think about whether x greater than 0 by itself is enough to answer this question. It works when m is less than n, so it works in conjunction with statement 1. But what if n is greater than m? What if we start with an equation like 4/2? So is 4/2, let me make sure I get that. Is that less than 4 plus x over 2 plus x for any x greater than 0? Well, let's add 4 to the numerator and the denominator. So then this would be equal to 8/6. This number right here is 2. This number right here is what? 1 1/3. So it's not true. If x is equal to 0, this statement still doesn't work if n is greater than m. So in order for this statement to be true, or in order to answer this question, you actually need both pieces of information. So both statements together are sufficient to answer this question. Next problem. 144. If n is a positive integer, so they tell us n is greater than 0, is 1/10 to the n less than 0.01. So they're saying is 1/10 to the n less than 0.01. Well, what's 0.01? I'll write it out. So this statement, that's another way of saying is 1/10 to the n less than 0.01 is 1/100, right? Which is the same thing as 1/10 squared. Right? So, well, let's just think about it a little bit. Let me look at the statements before I go off on my own tangent. So statement 1, they say n is greater than 2. So if n is greater than 2, as n increases, is that going to make this whole number smaller or bigger? Well, if I take a fraction, especially 1/10, as I increase it to more and more powers, I actually end up going more and more behind the decimal point, right? If n is greater than 2, at n equals 2, you get 0.01. And then if n is equal to 3, although it doesn't have to be an integer. Actually, they tell us it's an integer. So at n equals 3, what is it? If n is 3, so they say n has to be at least 3, right? And it's because it's a positive integer. So what's 1/10 of the third power? It's 0.001. And that's definitely less than 0.01. What's 1/10 of the fourth power? That's 0.0001. And that's definitely less than 0.01. So this statement alone is sufficient to answer the question. Statement 2. Statement 2. Another way you could view this is this inequality could be written as 10 to the minus n is less than 10 squared. And then this is only going to happen if minus. No, actually, that's not a good way to go about it. I think the way I explained it the first time is probably the better way. All right, the second statement they say is 1 over 10 to the n minus 1 is less than 0.1. So what we could do here is just multiply both sides of this equation by 1 over 10. And what happens? You get 1/10 times 1/10 to the n minus 1 is less than, what's 1/10 times 0.1? Well, it's 1.01, right? It's 1/10 of that. And what does this simplify to? You have 1/10 to the first power times 1/10 to the n minus 1. You add the exponents, right? You could put a first power there. Well, this is equal to 1/10 to the n is less than 0.01, which is the statement that we originally had. 1/10 to the n is less than 0.01. So statement 2 is actually equivalent to the original problem statement. So each of these statements independently are sufficient to answer the question. See you in the next video.